The views and opinions expressed do not necessarily reflect those of Access Fort Wayne, the Allen County Public Library, or any other supporting groups. If you'd like to produce a show, call us at 260-421-1250.
Let me be your lighthouse so I can show you the way. Let me be your shining light, I'll keep you from drifting away. I'm the one that makes you try when...
Hello. Hi, this is Patty Hunter of Patty's Page. Today I'm at Science Central, and today I'm with Martin Fisher.
Hi there.
Hello, Martin.
Hello, everybody.
And this is John Dickmeyer, my co-host. Hello, John.
Hello, Patty.
Oh, thank you. So we're here at the Science Central. What was this place before it became all of this?
Yeah, that's a really good question. We're standing in a very historic and iconic building for Fort Wayne. In fact, all of Northeast Indiana. This building used to be called City Light and Power. It produced electricity for Fort Wayne from about 1929 until 1975. And then it sat empty, dilapidated, vacant until our city leaders in the late 70s, early 80s, and 90s realized, hey, you know, this region of the country needed to have one of these hands-on, interactive types of science centers. So they found this building and repurposed it. And it's a fantastic building because not only are we near downtown, and not only are we near a lot of the interstates, but it still has a lot of the original pieces of equipment inside of this building. The camera zooms in, you'll notice that right over our shoulders, there's that giant red crane hanging down. That crane was used to be able to lift into this building a lot of the original equipment, which of course was very heavy. It's attached to an enormous beam that spans from one side of the gallery all the way over to the other. So not only could that hook move back and forth, left and right, but it could even move forward and backward from one side of the building to the other. Now there's one remaining generator inside of the building.
This one right there?
That's the blue thing over there. It produced the electrical field, produced electricity. It was attached to the yellow turbine, which you can see to the left of the blue generator. And then you'll also notice that there's a brick wall. Excuse me. That brick wall splits the building in half. This side of the building had the turbines and the generators. The other side of the building had the coal steamers. So on that side of the building, carts of coal would come in, and you would basically take that coal, cook it, burn it, produce heat to be able to convert water into steam. And then by altering the pressure of that steam, that's what operated the equipment on this side of the building. So that brick wall, those two sides, those two components were very important for coal to be able to be producing electricity.
Where'd you get the coal?
I would imagine it came from around the Midwest, but I honestly don't know where they got the coal from that time.
I thought there was coal mines here in Indiana, isn't there?
It's possible, and I know that coal is still mined here in Indiana, but as to where it was acquired during that 50, 60-year time span, that I don't know.
So you're not from Fort Wayne, are you?
No, I've only lived here in Fort Wayne and Indiana for about 9 years. I moved here in fall of 2007 to work with all of you that are watching and hopefully visiting. Since fall of 2007, I've been here working on exhibits, programs, partnerships, events, and activities.
When did you get on TV?
You know, oddly enough, I've been doing it almost since the day that I started here, but when I was working at a previous science center for 10 years, I was doing quite a bit of TV work there. And for about 5 years before that, when I was in another part of the country, at another museum, I did TV work then.
You see, Patty, museum work is not only doing the exhibits, but it's presenting the information. And you have to be, if you're a good curator or director, that's what you have to do, isn't it?
It is. You know, not only are we a nonprofit, which means that we're taking all of the money that's acquired to be able to put right back into programs and events. We're not trying to make a profit. And nonprofit status, that's a formal designation by the US IRS, but we're just like any other business. So whether I'm talking to any of you at home, or if you're on a school group that's here, or a high school career group, we're just like any other business. So that means that we have people in finance and accounting. We have people in marketing, graphic design.
Who's the sponsors?
Our sponsors come from all over the community, in fact, all over the region. Any business that's watching right now, if you're interested in sponsoring an exhibit or an event like our golf outing or a program such as field trips or our science camps, because we are a nonprofit, we do rely on donations, foundations, grants, and sponsorships. And those might come from individuals or businesses.
That's good. I'm glad that people are contributing, because this is very, very needed in this, this town, this city. I just want to know. Oh, you got a question?
Well, actually, what this organization is all about is science education on a very basic level.
It is.
Isn't it not? To spark the interest of younger people and even spark the interest of some of us that are older.
Sure. So if you think about it, what's a place like a science center trying to do? We want to create a scientifically literate community.
Right.
I want you to be scientifically literate. What do I mean by that? Well, one, if you come here with your family or on a field trip and you learn a couple of facts and figures about science, that's great. Two, if you come here and you learn those real world connections between science and what's going on in your lives and your community and the world around you, that's even more powerful. Three, if you come here and you decide, I can take some science classes, I can read a magazine about science, I can watch a science TV show, that's even more powerful. Four, if you come to a place like Science Central and you go, wow, science is fun. That's the most powerful of all. So if a person is able to acquire any of those four components, we're helping to create a scientifically literate community.
So tell me, what are the basic exhibits, hands-on? When you say hands-on, what do you do?
So it means that a person, instead of going to a case full of stuff, collections that they can't touch, all they can do is look at it, but you can't touch it, and there's a sign on the wall that has really, 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 really small font with lots and lots and lots and lots of information. That's a science museum. So museums, don't get me wrong, I love science museums. I worked at a science museum once, but they're for collections and research.
So this isn't really a museum.
Exactly. We don't have collections because we want visitors to touch our exhibits, and we don't do research. Instead of looking at a case with stuff behind it that you can't access, we want the visitor to touch the exhibit, manipulate the knob, push the button, turn the dial, to be able to have something happen. And what that would be, well, it varies from exhibit to exhibit. But all of the exhibits are about physical sciences, natural sciences, and applied sciences.
Oh, how about children? I mean, how do you go about showing children how to use all this?
Sure.
Does their parents do it, or the people who work here do it?
So it's all the above. It's the child, it's their teacher, it's their parent, it's the adults that may be coming in on their own. We have some interpretive signs, and the interpretive signs have a couple of components. They tell the visitor how to use that exhibit.
Yeah.
And then directly below it, a sentence or two, which will then give some information about that exhibit. What's the science behind it? And then the third piece would be how it relates to the world around them. So every exhibit sign has those three components in it. And it's not a lot of information. Maybe they only read one piece. That's fine. Maybe they only read one sentence. That's also fine. But then the child, they may just push the button, see the effect, whatever it is, and move on. But they've experienced that effect. maybe the adult is looking at it, reading the sign, pushing the effect, and trying it again and again.
To see how
So
it did.
so it really varies from person to person. Some people will just go from exhibit to exhibit to exhibit to exhibit. Other people will just kind of bounce around, going from one part of the building to the next. Maybe they don't even see all of the exhibits or try all of the exhibits, and that's okay as well.
Can't see this all in one day. You have to come more than once.
Patty, maybe you want to try an exhibit and see
Make some.
how it works.
Sure, I think we should go on a quick tour and take a look at a couple of them.
Do you have animals?
We do have some
You have
animals.
animals here? Like what
Yeah.
kind?
Well,
Fish?
we do have some fish, we have some frogs, we have lizards, turtles, hissing cockroaches.
Oh.
Yeah. So we try to have some
Those.
very tough and hardy animals that are good representatives of insects or amphibians or reptiles. Again, to be able to teach just basic science of biology
Snakes.
or anatomy. We even have snakes.
Oh boy.
Yeah.
Tarantulas.
Should we go walk around and see some things?
Sure. Go on.
Okay.
What's your favorite?
My favorite exhibit? I've got a lot of them, to be honest with you. But tell you what, why don't we go take a look at one of our Science of Sound ones? Because I really like this one. And we're here at a good time. The building is empty, so you'll be able to get the full experience of it. All right, so this exhibit is an echo tube. And you'll see that it's basically this really, really long tube that starts here, almost at ground level, and goes all the way to the top and about 3-4 stories up. Probably at that point, it's about 4 stories up, all the way at the back corner. And it's placed right up against a wall. So of course, sound would go up, hit that wall, and reflect off. We're here at a perfect time right now because I've got walls to the right, walls to the left, walls all around us, and we're all familiar with an echo. You know, you're in the Grand Canyon, you go echo, echo, and it comes back. If I clap my hands,
I don't. They work.
we can hear the echo. But what makes an echo tube so interesting is that it's a very narrow diameter and a very long tube. So it's actually able to, believe it or not, separate out the sound waves. Every sound, doesn't matter if it's my hand clapping or our voices, are a mix of long, slow-moving wavelengths and shorter, faster-moving wavelengths.
I used to take that in physics.
Yeah, basic physics. You realize that a single sound is a mix of long and short wavelengths. This exhibit can separate out that sound. So the faster, shorter wavelengths come back sooner. The slower, deeper, longer wavelengths come back slower. And if you come up with the camera, you'll actually be able to get the microphone right to the opening. Listen to this.
Oh.
Bam! That's because the faster wavelengths, which are smaller and shorter, come back faster and a higher pitch.
Yeah.
So it goes bam. And you're not going to get that effect without an echo tube. So in the room like this, it just sounds like one sound. This is one of my favorite exhibits.
Why don't you try it, Patty? Get up here closer
Sing for us.
and say something.
Well done.
Sounds like it
the
sounds
crowd
like a-
goes wild. Wah, wah.
What if you speak into it?
Speak.
Heal. Hello. Oh boy.
Try that again.
Good. Are you a singer?
I am not.
Neither am I.
One of the interesting things about a science center is that our exhibits never stay static. We're constantly changing, removing older ones, updating older ones, and putting in new ones. As a perfect example, the solar system exhibit that's behind us over here, probably about 25 exhibits relating to our planets and technology
Oh,
about space exploration.
see it now.
These are all new. They're on both this side of the fence and on the other side of the fence. We've got a bunch of engineering exhibits about simple machines, structures, architecture around the corner that are also brand new.
What's a
So-
balance stick?
The balance stick? So, that's an interesting one. You've all seen people do magic tricks or balance tricks. They'll balance a broom on their fingertip.
Right.
Well, there's science to it. There's physics to it. when you have a mass such as this blue cap, the higher up you can get it, the higher up the center of mass is.
Oh.
And if I'm lower, well below the center of mass, I can easily adjust my position underneath when it starts to topple.
Oh, manipulate.
With the shorter stick, it's a lot harder to balance it, really tough.
So you need a big-
So, exactly, you need a bigger stick, you need a bigger broom. So we'll start putting some of these pieces together. Let's see,
Just like that movie. Looks like we need a bigger box.
there we go,
It's Godzilla.
and there we go. What is this, like the movie Jaws? We're gonna need a larger boat. All right, so actually this one's pretty good. So this should be much, oh yeah, much,
That's a lot.
much easier.
Oh, I like that.
So as it starts to tip over, because the center of mass is higher, it's easier for me to move the ground point,
Oh.
which is known as the
3D.
base of support, where something comes in contact with the ground, or my finger. I can easily adjust my base of support underneath it, the taller it is. Unlike this.
It's too.
Oh,
Yeah.
much,
Wow.
much tougher.
I took astronomy many moons ago, night course, all about planets and stars and everything like that. I've always been fascinated by it.
Astronomy. Hey, do you want to see a really neat astronomy exhibit?
Yeah.
What about you guys watching at home? Do you want to see a really neat astronomy exhibit?
We want to see.
Good answer, good answer. Come and follow me. So this exhibit is known as Science on a Sphere. Science because we teach science. Sphere because it's spherical in shape. This thing, believe it or not, was invented by the United States government, NOAA, the National Oceanic and Atmospheric Administration. And it looks like a hologram. It looks like it's kind of floating there in the middle of the room, but
Watching
it
too
is
much Star
not.
Trek.
We're watching a movie. That's it. So watch this. I'm going to put it on pause and it stops moving. It's not a hologram. This is not magic. What we're looking at is a 50-pound hollow sphere that's suspended by 3 guide wires up above. And if you look carefully, you can see the cables attaching it. And then on each wall, there are 2 projectors, 2 over there, and then 2 behind me over on this side. Those projectors are basically shining a movie, projecting a movie onto a screen. It just happens that the screen is spherical in shape, and it's all coordinated by the computer room that's directly in front of me right now.
I've always been interested in the stars and their planets.
And this is the room to see it. This computer is directly connected to the Science on a Sphere office that's run by NOAA, the National Oceanic and Atmospheric Administration. They're within the Department of Commerce. So commerce, of course, is important for trade. You want to know climate, you want to know weather conditions, you want to know currents, you want to know fisheries. All of that is within the Department of Commerce.
Can you do that here or just?
Oh yeah, I'm connected to them right now, and I can show those images with the sphere. NOAA, they wanted to be able to understand Earth systems. Think about NOAA as the Earth equivalent of NASA. What NASA does for space, NOAA does for oceans and for the atmosphere.
What is NOAA again? What's this
The
show?
National Oceanic and Atmospheric Administration.
Oh.
So I want to show you something really cool. Told you this is just a movie, right?
Right.
We have total and complete, we have control over it. Actually, I'm going to let you have control over it. First, we'll show you the screen. Using this iPad, I'm connected to the computer room, which is connected to NOAA,
Yeah.
and I have access not only to control the projectors, the movies that they're shining, but even the images, which are called data sets. Take one of your fingers and just move it back and forth on any of the arrows. Doesn't matter which one. Take a look at what you're doing. Remember, this is not moving. It's just a
It's a
sphere.
movie.
It's the movies being projected, there we go.
Shown.
Projected through the projector, sounds redundant. That's changing. Much more gooder. So, like I said, we have hundreds of images that we can show. For example, I'm going to connect live time to all of the earthquake monitoring stations that are run through various universities and governments all over the world. And then all of that data is fed to the U.S. Geological Survey. So I'm now connected to the U.S. Geological Survey. Every one of those circles represents an earthquake. And if you see the date stamp on the bottom, it's going to go right up to today. In fact, I can even fast forward it. May 2nd, the day and the hour that we're filming this, you can see earthquakes that have occurred today. Now you'll notice that a tremendous number of earthquakes, I'll put it back into motion, occurs along the Pacific Ocean. And I'll move it over from the west coast of South America to the west coast of the United States.
This is a shelf.
There are there are oceanic plates and continental plates that are grinding against each other to Alaska, Aleutian Islands, over to Asia, and down again. That's where most of that earthquake activity is occurring. It's known as the Ring of Fire, because that's where most earthquakes and volcanoes are occurring. And you'll notice, smack dab in the center of all that activity, all those circles, that's Hawaii. America's favorite vacation spot is also where the newest Earth on Earth is being formed because of volcanic eruptions. Oh, but wait, there's more.
How about Greenland?
Let's take a look at currents that go right by Greenland. So you can see there's South America, the outline of it. There's North America.
Look at the Gulf Stream.
We take a look, exactly. You can see this nice warm water from Africa striking South America, getting deflected north
That's why we're
to the
having
west
hurricanes
coast,
and
excuse me, the
tornadoes.
east coast of the United States.
So the tornadoes and hurricanes, you can just follow the stream.
This would definitely, we even have access to information such as hurricanes. And I'm going to try to find, I've got Hurricane Katrina in this playlist somewhere. I probably should have put on my reading glasses, huh? Give me a moment. There we go. Here's Hurricane Katrina from 2005. This shows all of the cloud systems. I'm going to drop it down so we can see it a little bit easier and spin it around. So again, to orient you, here's South America. There's North America.
Right.
There's the Atlantic Ocean. So I'll put it in motion now. Tropical depression to tropical storm. Then it moves into hurricane status. Pause it. There's Hurricane Katrina making first landfall over Florida.
Is that a supercell?
This would just be a hurricane that's formed at this
Do
point.
we ever have supercells here in America?
Well, it depends what term you're using the supercell as.
Supers.
Let's finish taking a look at this
Okay.
data set. That's okay. Because watch this. Once it gets into the Gulf Stream, now I'll pause it. You can see the distinct eye of that hurricane. Katrina makes landfall in New Orleans. Pause it again. We're in Indiana right now.
Yeah.
But look at those storm clouds. They made it all the way here into Indiana, northern Indiana at that. So not only do we have access to images from NOAA, but we also have images from NASA. We're taking a look at the moon right now.
Oh, look at the moon.
The moon doesn't have an atmosphere the way Earth does.
And
So when comets, debris, meteors, asteroids pummel it, it strikes the surface and sends out that plume across the surface. And you can just see all of those impact craters everywhere that you look. Here's Mars, another image from NASA.
Mars.
And we can take a look again to see a planet almost the same size as Earth. It doesn't have an atmosphere, so it too is able to get hit by comets, asteroids, meteors, and so
Well,
forth.
Earth has had.
This strange looking thing, that long line going from left to right, that's a valley known as Valles Marineris. It's the length of the United States, east coast to west coast, and it's deeper and longer, obviously, than the Grand Canyon.
Do you think there's life in there?
As of now, scientists have not been able to find any microorganisms as to whether there was in the past. Who knows? As to whether there still is, again, who knows? But that's why science research is so important. Not only because we have pure curiosity to find out more about our own planet and other planets, but also for the value of scientific research and what it might be able to do for humans in the future. That's why it's important to send space probes, satellites, as well as eventually, hopefully we'll have people that will be able to go to Mars to be able to do additional research.
And there will be life on
And there would be. And we'll have real Martians at that point.
human.
Tell you what, why don't we go take a look at one of our quick science demonstrations?
Okay, that'd be great.
We're the only science center really in this region of the country. It's not until you get to the Ohio cities of Dayton, Columbus, Toledo, Cincinnati, and you go up north to Detroit, go west to Chicagoland, go south to Louisville. I should say it right, Louisville. I think I got it. We're the only science center that's really in this part of the country. And one of the nice things about the science center field is that it's a very tight-knit group. We strongly believe and advocate for science education. If you get a membership at a place like Science Central, you can get into hundreds of other science centers for free.
Wow.
Our membership, at least for a group for here, would allow 2 adults and any 6 kids to come in for free. Now, other science centers will vary as to how many or who they would let in. But for us, it's 6 kids and 2 adults. And those 6 kids don't need to live in the same house as the 2 adults. It could be cousins, grandkids, doesn't really matter.
What do you want me to do?
I'm going to have you also wear some gloves and goggles. So,
Sure you trust me?
I do. It'll be safe. All right, you put on those 2. After you put them on, go ahead and put the goggles on.
Orange.
Can you make it interesting, turn her green or something? I mean,
Turn me green. Just give me the
The
wrong
question is,
color.
will it be permanent or not?
I'll be a green light. I'll be a green. Like, I'm Irish, so green and me go naturally together.
All right, let's go to this side, I think. We'll go to the front of the table. That might be a little bit easier. All right, so what we have inside of here is liquid nitrogen. We're surrounded by nitrogen right now. It's the most common element that's in our atmosphere. About 78% of our atmosphere is nitrogen, which is right over here, number 7, nitrogen. Nitrogen is a gas. About 20% is atmosphere, and the rest is everything else. But it's nitrogen as a gas in our atmosphere. Inside of this container, it's nitrogen as a liquid.
Oh.
Liquid nitrogen, really, really cold. 320 degrees below 0 Fahrenheit. That's why we have the safety equipment on. So, when I pour it into this glass beaker and the camera zooms in, you'll notice a couple of things. One, it's clear. We can see through it.
Yeah.
Second, it's colorless. Doesn't have red, yellow, green, orange, purple, Scotch plaid, or anything else. And it's boiling. It's bubbling. It's changing from a liquid into a gas. It's boiling at room temperature. That's because the room around us, I don't know,
that
70 degrees Fahrenheit. It's a whole lot warmer than this stuff, which is negative 320 degrees Fahrenheit.
How do you liquid nitrogen?
There are gas supply companies that have really long columns, and what they do is they're removing gases from the atmosphere, and then at different layers of that column, they're able to cool it enough to be able to remove liquid oxygen, liquid nitrogen, and so on. All right, here's the next thing. You see all this smoke or steam coming out of it. What I want for you to do is to just stand up about a foot away and then just blow some air down into it. Do it again. It's okay, it's perfectly safe. Yeah, there you go. What we're looking at is, fancy word, condensation. There's always water that's in the atmosphere around us. And if you make that water cold enough, it will condense. It sticks
There's water
onto
everywhere.
dust
In
particles,
us.
even in the desert. So what we're looking at is water that's condensing or sticking onto steam. All right, here's the next thing. If you make something colder, the molecules move slower and move closer together, and you can decrease the volume of something. So what I want for you to do is just hold on to one end, don't put your hand into the liquid nitrogen, and then put the balloon into the liquid nitrogen. I filled this balloon with gas, just normal gas from the atmosphere, used a balloon pump.
Shrinking.
As the gas on the inside gets colder, because we're cooling it, the molecules of gas move closer together, the molecules of gas move slower, and the volume of the gas in the balloon decreases. So we were able to take that really long balloon, and we could keep taking balloon after balloon after balloon and putting it in there. So of course, if you do the reverse, take it out and warm it up, as the gas in the balloon gets warmer, the gas molecules move faster, the gas molecules move further apart, and our balloon increases in volume until it returns to the original size we had before.
What do you use that for? In
industry, it would be used for cooling off equipment, electronics, technological pieces. In the medical field, they would use it for even removing warts for cryosurgery. So we've just seen one of the many, many demonstrations that we do here at Science Central. We do these for schools that are on study trips to Science Central, as well as after-school clubs, youth groups, scout troops that may come in on an afternoon or a weekend. We have many, many, many different programs that we offer, everything from weather demonstrations to chemistry to electricity programs where we can make people's hair stand on end, and of course the very popular Science of Temperature program.
Are you people from all over the nation come here?
They do, and of course during vacation time, spring break, summer vacation, winter break, people are definitely traveling all over the country. Now during the school year itself, most of our visitors tend to be local from the tri-state area, Northeast Indiana, Southwest Michigan, Northwest Ohio.
John?
Wow. This is a wonderful place. But I can tell you a story back from 1965. This particular plant lightened my life back in '65 because all of the surrounding area was blacked out by tornadoes. And the only lights in the city of Fort Wayne came from power coming from
this power plant.
This power plant.
I heard about that, yeah.
Yeah.
Where's the other one? The one nowadays, where is that located?
Most of the power nowadays is coming from up north. That there's a nuclear reactor that Indiana, Michigan uses off the lake.
Mm-hmm.
Well, sir, Martin Fisher.
Thank you so much. I enjoyed
you for
working with
coming
you,
on
enjoyed
to
meeting
the
you.
show.
Thank you.
Sure, you have a great day.
Can I get a hug?
Sure, of course. Thank you.
And this is Patty Hunter of Patty's Page. I'll see you next week. Hope to hear from you. Bye-bye.